Hey class, this is going to be Chapter 8, Lesson 2. If you haven't already, I really need you to do the Khan Academy videos from yesterday on Lessons 1. Lesson 1 ties directly into Lesson 2, so if Lesson 1 was a struggle for you, please go back and do some extra practice and really lock it down before attempting this lesson. This one will get harder, okay? Now we're going to start to find the area of circles. So we're starting on page 624. I skipped a couple questions on the previous page. You can answer them or not, but we're going to jump right in and look at some formulas. So the formula for circumference, there were two of them. When we were just looking around a circle, we had two formulas. C is equal to pi d. Let me zoom in and remind you what those were. Equal to pi times diameter, or you had the choice of using the radius. So C is equal to 2 pi r. Two pi r. Okay. Now we don't get a choice for area. You get one formula for area. So this might be easier for you, but if you are struggling to learn this one formula, you don't have an option to learn a second. So this is the only one for area of a circle. Area equals pi r squared. Now you might have heard people say this before, or you might have heard it in a Khan Academy video, or maybe you have an older brother or sister that has said pi r squared, but this is a very, very, very important formula that helps us to find the area of any circle. So we're going to go down to the bottom. We're just going to try to knock out some of these examples. So they give you two examples in here. You can read through them. If you pause the video, I recommend it. Take the notes on examples 1 and 2 before you attempt A with me down here at the bottom. So please pause the video and try that first. Okay, now we're going to attempt letter A. And just to remind myself, for every single problem, I'm going to want to write the formula. Area is equal to pi r squared. Okay, if you guys were in class, I would make you write this formula for every single problem. Not because I'm being mean, but because it needs to stick in your brain. Not only that, but you need to show your work. So you need to tell me which formula are you using. For every single one of these problems in geometry going forward, that means all of chapter 8, you're going to need to show me a formula for every single problem. Okay, now I'm going to start to look at some of my keywords here. So it says that they gave us a radius, which is actually good because r is right there in the formula, so we can plug that right in. So I'm going to use red, area equals pi r squared. For this one, I'm going to use 3.14. The reason I'm going to use 3.14 is because 3.2 is not compatible with the 7 in the denominator of 22 over 7. So when I'm looking at my choices for approximations of pi, 22 over 7 isn't going to be as helpful to me. Okay, or 3.14. I don't really want to use, okay, trying to get this to work. I don't really want to use this one today. I'm going to use 3.14, or at least for this problem. So let's plug that in for pi, 3.14. Let's plug in our radius. Again, I'm going to put this in parentheses. Every time you plug in a number, like radius or pi, you should put it in parentheses. So I got to learn, I have to follow my own rule. Put pi in parentheses, put radius in parentheses, 3.2, and we're going to square it. So what you're going to need to do is you're going to need to do PEMDAS here. A lot of people make a mistake and they multiply these two numbers first. That's a surefire way to get you the wrong answer. So if you need to, grab a calculator and go ahead and do PEMDAS. PEMDAS, the first thing you're going to need to do here is do this square. So 3.2 squared. I'm going to do that on the side of my paper here. Or you can use a calculator. 3.2 times 3.2. That's going to be 64, and then a 0. And then let's move this down to get more room. And then you're going to have a 6 here and a 9 here. Add that up. It's going to be 4, and a 2, and a 10. Okay, move the decimal 2 times. So that's going to be 3.14 times 10.24. Okay, and this will get us the area. So now the last step is just to multiply these. So our final area, and again, you can use a calculator, and it does say round to the nearest tenth. So your final answer here is going to be 32.2 centimeters squared. Now, one quick note about our units here, your centimeters are going to be squared anytime you are dealing with area. So again, it's really important to show all your work because since I have this A in the front, A for area, I am going to have squared units. No, this isn't going to change the number. I'm not going to then go turn around and square 32.2. I'm not, the square is not on 32.2, the square is on the units. It's just telling me that instead of measuring with a straight line like a ruler, I'm actually measuring a 3D space. Okay, so it's more like measuring with little centimeters that are squared, literal squares. Okay, so this is why circumference was measured with centimeters and area is measured with centimeters squared. It's a little bit different. So make sure to take note of that. Those are the units that you'll be using. Go ahead and find the next example, letter B, on the next page, page 625. Here we go. This time, we're going to use the exact same formula. It has not changed, and we're going to need to write it down every time. Area is equal to pi r squared. And now let's look for that keyword radius, because that's really what we need to plug in here. The bottom of the circular swimming pool with a diameter of 30 feet is painted blue. How many square feet are blue? Well, we've got a problem here because we don't have radius, but they gave us diameter. So we can't cheat and plug in 30 feet for R. That won't work. Again, this is another surefire way to get the wrong answer. We need to make sure that it's in a radius, it's a radius measurement, not a diameter measurement. So what do we know about diameter? We know that diameter is twice as big. So we also know that our radius here is going to be 15 feet. And we're going to plug that in instead of 30. So area is equal to pi, whatever approximation we choose to use. Since 22 over 7 is not compatible with 15, I'll probably use that decimal again, 3.14. And then we're going to plug in 15 and make sure that it is squared. Okay. Again, you should use your parentheses so that you don't forget which goes first. So I'm going to make you do this one on your own. You're going to want to square 15 first. And then whatever answer you get, you're going to multiply that by 3.14. Go ahead and pause the video before you sneak a peek at the answer. You can use a calculator, show all your work. And your final answer is going to be the area equals 706.5 feet squared. Now, no cheating. If you forgot the feet squared, you missed a point. So make sure that you fix it. We're dealing with area. We need to make sure that it's feet squared, not just feet. Okay, last one that I'm going to do. This one's going to take it one step further, and we've got semicircles now. So basically half of a circle. And so the formula makes sense. If you take a sneak peek down here at the new formula, area equals 1/2 pi r squared. You probably just could have thought about that off the top of your head. If it's half a circle, it's going to be half of pi r squared. We're going to use that down on the next example. If you haven't done so already, please take notes on example 4 so that you know what to kind of look out for here. Okay, this one says approximate the area of a semicircle with a radius of 6 centimeters. So they did do something nice for us. They gave us back the radius. We don't have to think too terribly hard about this one, but they also said semicircle. So these are our two key words that are going to help us to determine which formula to use. So let's give ourselves a little more space here. We know that we're going to need to use area equals 1/2 pi r squared. We know that for pi, again, this time we're probably going to want to use 3.14 because, again, 22/7, the 7 is not compatible with the 6. They won't cross out, so there's no point in using it. So let's use 3.14 instead. You do have a choice. If you like fractions in general, you can always use 22/7. I just like to use the easier number for me, so this is my choice today. And then the radius is, again, 6. Make sure to plug everything in. Do not skip steps. This is what your work should look like. It is required. Okay. From here, we can start to pick apart our PEMDAS. Okay, the first thing that we're going to need to do is exponents. So I know that 6 squared is 36. And then I can do the multiplication pieces. There are 2 multiplication pieces. I can do them in any order I want. So I could do half of 3.14 and then multiply by 36. But I think the easier thing to do, because I can do it in my head, is take half of 36 and then multiply by 3.14. So half of 36, if I cut that in half, I get 18. So now all I have to put in my calculator is 18 times 3.14, and that'll get me my answer. So making sure to fill everything in. Don't skip steps like I've tried to do, because my computer isn't wanting to work with me here. Your final answer for this one is going to be 56.5 centimeters squared. And that's your final answer. Okay, go ahead and work on the practice problems on page 626. I will have answers here on the notes for you, and then complete your homework for the day. Good luck.